Hello, good morning, everyone. It's a real pleasure to be participating in the Tech User Group Conference. My talk today is about interactive compilation of LaTeX for web browsers. I can be reached at jxxcarlson@gmail.com. If you have any questions or comments, there's information about the subject of this talk at MiniLaTeX.io. So what I would like to talk about today is a technology which I called MiniLaTeX. The reason for the name is that it is a subset of LaTeX. It's designed for the web. That means that you can use it anywhere you have an internet connection. You can use it on any device, from a desktop computer to a smartphone. You can use it for things like course notes. Later on, I will show you some course notes that I wrote using a MiniLaTeX app. You can use it for quite a variety of things. That's one good use of it. So I think the best way to show you what MiniLaTeX is to do a little demo. So we're going to go to demo.minilatex.app. Here we are. On the left, you see a little window with source text in it, with LaTeX. On the right, you see the rendered version. And you may not have noticed it, but what happened is when this browser opened the app, it essentially instantaneously parsed and rendered the source text to display it on the right. And what we see on the right here is a rendered text document. If I click on an entry in the table of contents, let's try that again, we go to the corresponding place in the rendered text. There you see some images. One is a PNG image, something I saved to my desktop and then uploaded to a server someplace. Another is an SVG image. Let's see how these are constructed in the source text. I'll scroll down here on the left. And under section images, we have this little macro here, \image. That's what's used to create the little waveform, the 2 frequency beats. It's a macro that takes 3 arguments. There is, the first argument is a URL for the image. The second argument is the caption. And the third argument is some placement data, the width, how it should be put on the screen, whether floating on the left, aligned in the center, and so forth. Below that, you see something a little bit different. This is an SVG environment. And what you can put inside the SVG environment, inside the begin-end pair, is raw source code for an SVG image. I constructed this image using an SVG editor. You could write the SVG code by hand, produce it algorithmically, whatever. Let's scroll up a little bit to see what else we have here. Conventional mathematical stuff. Let's scroll up on the left to see the source text. And what you see is, first of all, let's look at this one here. We have an equation environment. Inside that, we have a label for cross-referencing equation 2.1, and then we have the actual formula itself right here. Let's see what happens when we edit this thing. I'm going to change the 1 to a 2. So look carefully on the right-hand part of the screen. There it is, it's changed. Let me edit this so we have a correct formula. I will edit the numerator of the fraction. It will be 2 to the power n plus 1. There we go, and that's rendered again. So you see this is live editing of text, of LaTeX text, and it renders essentially immediately. So later on I'll talk a little bit about what the technology involved in making that happen is. So we should see what happens when we make mistakes, because we all do that. Let's go to try it out here, section try it out, and I will eliminate the right brace. And if you look in the rendered text, you see that you have an error message. Error messages appear inline. They give you some idea of what it is that you did wrong. So in this case, it's pretty accurate. It says expecting right brace. So one of the projects I'm working on is to improve the error reporting. I would like to make the error messages as helpful as possible. If I put the right brace back, then I get my text back, but we notice the number before try it out is gone. It should be 2, try it out, section number 2. The reason for this is that MiniLaTeX is a logical paragraph-oriented application. What does that mean? A logical paragraph is either an ordinary paragraph or it's an outer begin-end block with space above and below. And these are the basic units of compilation in MiniLaTeX. So if you edit something or you make a mistake, it will be, all the changes are relevant to that particular logical paragraph. This means 2 things. It means that errors don't propagate. It also means that rendering can be very fast because the program keeps track of what's changed and it only re-renders what has been changed. So anyway, things have gotten out of sync now. And to rectify that, we go down to this other button here, full render. I press that, and now everything is back where it should be. Except, of course, I've changed my formula. Now, by the way, this little app is one that you can use at your heart's content because there's no data to destroy here. Let's press the restore button, and now it brings the text back to its original state. So this is purely for demonstration purposes. Let's go up and see one more thing here. At the top you see, on the left you see begin math macro. So the math macro environment is something peculiar to MiniLaTeX. There's also begin text macro, which you see down here. And these are environments within which you can define your own math mode and text mode macros. So let me give you an example of that. I'm going to define a new macro for you. I'm going to say new command, curly brace, \ww. Whoops, let's try that again, ww. And then even if it's a macro or a new command of 0 arguments, I have to specifically say this. In a future release, I'll probably get rid of that, but for now we have to do that. And then I'm going to say we're going to interpret that as math BB of capital W. Okay, so I hope I haven't made any mistakes, but I've made a new math mode macro. And down here, I'm going to try to use it. I'm going to say $. I have a mistake over there. You see the error message, $. I'm going to put something inside here. I'll put \ww. Notice that it hasn't recognized my macro yet, but I'll keep typing anyway. Type some ridiculous formula here. Maybe this. Okay, so I have a formula, except of course my macro has not been applied, and to rectify that I say full render again, and there, by golly, you see it, okay, right there. Okay, so that's a brief introduction to what MiniLaTeX can do. Notice, by the way, there's been no setup for the document. There's no preamble here. Maybe I should give you an even quicker intro to that. I can clear this window, and then I can just use it to experiment. Like I can say Pythagoras, I can't type today. Pythagoras said that a squared plus b squared equals c squared, and close the $. Okay, so I've written some text in there. And as I say, you can use this to experiment with various MiniLaTeX constructs. Another thing you can do, let's restore the original text. There we go. Notice this final button that we have not used, export. So if I press export, then it downloads a text document to my computer. Let me go to my downloads folder. What it's done is it has translated a MiniLaTeX document to a regular LaTeX document, and that I can typeset with any text program that you might want to use. I'm using TextShop, should do this twice. And there we have a text version of my MiniLaTeX document, complete with images. I'll have to say something about them in a second. Notice, by the way, that here it says cannot yet render SVG images, convert to some other format, e.g. PNG. So bear that in mind. Now, how did it take care of the images? Because the image macro refers to images that are on the web someplace. Well, if you noticed, when we exported the document, a little column with images appeared on the right, and if I do right-click or control-click on a Mac, then I can say Save Image As, and what I do is I save it inside this image folder, which is where TechShop or whatever tech program you use will look for the images. So in that way, any images that you might have used in your document will also be accessible when you export the document. So I think that is all that I wanted to say about that demo. Let me just quickly look here. Well, I believe that's it. There are a couple of other things. Let me go back here and clear this once again. And let me show you what happens when I make this kind of error. I will say string theory. So notice what's happened. The string macro doesn't exist, so it's rendered that in red. That's the best it can do. I was really thinking of strong theory. So if I type that, well, if I get it right, then it will render that in bold. So that's a good thing to know. Here's another one. I can say this: begin joke. End joke. And it renders it like this. So if you use an environment that MiniLaTeX does not understand, it tries to handle that as gracefully as it can. That can actually be useful. I mean, maybe I want to write a manual about humor, and this gives me a ready-made joke environment. If I were a lawyer, I could have objection environments and so forth and so on. And of course, if you export the document, you can define your own joke or objection environment to handle it in a different way if you wish. So I think that's everything that I wanted to say about this demo app. So slight pause here. I want to do one more demo, and then I want to talk about the technical aspects of writing a LaTeX to HTML compiler. So welcome back to part 2 of this 3-part series on MiniLaTeX. What I'd like to show you now is an app called MiniLaTeX.Lamdera.app. It's a full-fledged document management app, and it can be used in a number of ways. The first way is to simply click on a link. The link has the form the app name /G for guest / a number for the document number of some document. So let's try that. That goes immediately to the document, and now you can click on the table of contents. This is a good way of distributing class notes, for example. The second way of using MiniLaTeX.Lamdera.app is to log in as guest. The instructions for that are given here in this little welcome message, along with lots of other useful information like features. But we do it like this. You put in guest as the username, you put in MiniLaTeX as the password, and you sign in, and there you are. Okay, now we've seen much of this before, so let's look at something different. Let's search for LaTeX. That narrows the list of available things down. Let's click on MiniLaTeX Tug Talk. That's the written version of what I'm trying to say now. Of course, the two versions diverge. But anyway, you can mess around with this. One thing that I plan to do is to add a lot to the search feature, because right now there are very few documents, but hopefully there will be many more in the future. And we need ways of finding documents pertaining to a particular class, a particular author, certain subjects or tags, etc. So I think that is probably everything that I want to say about guest mode. We've seen most of it before. For example, you can look at the source, which is always a useful thing to do. So let's sign out, and we'll look at the third and last way of using it, which is to sign in as a real user. I'll sign in as myself. There I am. And there are only a few different things that you need to know. One is that, of course, you now have access to this button, which allows you to create new documents. Let's make one, let's call it test, something not very interesting. And we'll have just a simple little message there. Notice, of course, that it was rendered immediately. I have to press the title button in order to set that. And if I wish to publish this document, then I just go over here and I press publish. I can change back and forth, okay? I haven't implemented search on tags yet, but I can set tags as well if I wish. More importantly, down here below, you see a button called Collaborators. If I want to, well, I guess I'm already collaborating with Fred, but maybe I also want to collaborate with Mary. So I say Set Collaborators, and now Fred and Mary can also edit this document. And something that's rather nice is that if we're all editing at the same time, then we will be able to see each other's edits in real time. If I go off to lunch and log out, come back, then I'll see their edits after I log back in. To facilitate collaboration, there is also a chat feature. There's not much in the chat right now because this is still sort of a test run for the app. But it's there, and I plan to make additions to that also. So, for example, there will be channels for particular documents. Right now, everybody's in the same channel, which is not so great. So I believe that is all that I wanted to say about this app because we've covered all the other features and other things. So let me now go to the third and last phase of this talk, which is to talk about how we actually implement a compiler that will transform LaTeX to HTML and also do it in essentially real time because that's what we want. Well, the first thing that you need is the right tool. And for me, the right tool is a language called Elm. It's a language that takes Elm source code and it compiles it to JavaScript. Now, most web developers use scripting languages that do not use a compiler. And I'd kind of gotten used to that, even though in the old days I did use compilers, like a Fortran compiler. Let me tell you that it's great to be using a compiler again because you don't have runtime errors anymore. It's just wonderful. Elm is also a strictly typed language like Haskell or ML. In fact, syntactically, it has many similarities to those languages, and in fact, the Elm compiler is written in Haskell. It's a functional language. Now, this can mean many things. It may mean only that functions are first-class objects in the language. But Elm is what's called a pure functional language, which means that functions are like in mathematics. The output depends only on the input. There are no side effects. So let me talk a little bit about the amount of code that is necessary to implement the apps that I have showed you. The demo.minilatex.io app is only 320 lines of code. Okay? It also doesn't do that much, but it does render LaTeX. And the reason it can do that is that it calls upon the MiniLaTeX compiler, which is a little over 6,000 lines of code. Now, the heart of that compiler is the parser. That was actually the hardest thing for me to write, and that's just under 500 lines of code. On the other hand, this document management app, MiniLaTeX.Lamdera.app, is longer. It's a little over 5,000 lines of code. So that gives you a rough idea of how big things are. So let's talk a little bit about how we can transform source text to HTML. The key is this triangle here. We don't want to take source text to HTML directly. That would be way too hard. What we first do is we parse it. we transform it into something called an abstract syntax tree. It's a tree structure, a graph of sorts, that expresses a kind of grammatical understanding of the source text. Once you have that, it's actually rather simple to render it to HTML. So let me give you an example of an AST in a different language. It's not Python, but pseudo-Python. So there's a little bit of code, and there's the corresponding AST. It's a tree, okay? And if you look at the nodes, you see that certain nodes like while and branch and assign correspond to certain linguistic categories in that pseudo-language. Now, what about MiniLaTeX? There's a little piece of LaTeX code, and there is the corresponding syntax tree. And if you look at that, you see things like macro, which has its children strong, and then a list, and then a LaTeX list, and et cetera, et cetera, et cetera. I really don't have time to go into this more, although of course it's fascinating. But the main point is that in order to get this off the ground, you have to think about the type of the abstract syntax tree. So remember, I said that Elm is a strictly typed language, and this is the key for doing this. So here it is. It actually fits on a page. The type is something I call LaTeX expression, and it contains things that will be familiar to you. A piece of LaTeX text might be just ordinary text, and we have to identify it as such. So that's an LX string. A string might also be a comment. We have to identify that as such. It might be we have items in itemized lists, so we have to identify those. The int part corresponds to the level of the list. We have math elements, inline and display math elements, and we have to separate those out and identify them. And we saw that, by the way, when we looked at our little example. The Pythagorean theorem was, or the Pythagorean formula rather, was the body of the inline math element in that tree. Let's go back and look at that. There we go. You see there inline math, quote, a to the power 2, etc. Okay, so back to the LaTeX expression. So you just enumerate all the things that you know you need to do in LaTeX. You have to have macros. A macro has a name, it has a list of optional arguments, and it has a list of arguments, and those arguments themselves may be LaTeX expressions. So this type is a recursive type. Same with environments. They have a name, that's the string. They have possibly arguments, and then there's the body, which I just parses it as a string, unprocessed. And finally, something I added later in the project was the ability to define text mode and math mode macros inside of a MiniLaTeX document. So you have to have a component of the type for that. A new command has a name, it has an integer number of arguments, and then it has a LaTeX expression, which is the body of the macro definition. And then finally, you have LX error to deal with errors, because of course those happen too. So that's really the fundamental element. And when I started working on this, I didn't have a grammar to work with, which is what you usually want when you want to make a parser. But I'd used LaTeX most of my life, and I sort of had a feeling of how to build the definition of the type of the AST. Well, let me show you a little bit about the parser. Again, this is a big subject, even though it's only 500 lines of code. But here's the idea. The top level parser function looks like this. It's called LaTeX expression, and it is a parser that selects among a number of alternatives. So it's built using what are called parser combinators. So one of is a parser that takes a list of parsers as argument, and it will try to apply those parsers in turn, returning the result of the first one that succeeds, and if they all fail, it will return an error. So it first of all tries to see, well, do I have a text comment? No, I don't. Do I have a displayed math element? No, I don't, and so on. Well, eventually it will either succeed or it fails, and then it goes on to the next thing. Let's look at one of these. Let's look at the macro parser. So this is a different kind of parser. Instead of selecting among alternatives, what we have here is a parser pipeline, and it sequences parsers. So what it does is this. It first of all tries to identify the macro name. That's the macro name parser. Then it tries to identify the list of arguments. That's the item list optional arg parser. So optional arg is a little parser, and item list is a combinator that combines those optional arguments parsers to parse a list of arguments, and so forth and so on, okay? We have not only optional arguments, but actual arguments, so we have to parse those, and then we eat up whatever white space is left. And the reason we do that is that this kind of parsing technology does not separate the operations of lexical analysis and parsing. So everything is all in one big system, or one little system, as the case may be. A few words about the renderer. So this is a much larger piece of code, but it's also a much easier piece of code to write. And basically what you have to do is to write a rendering function for every component of the type of the AST. I also use a divide and conquer strategy, which is what made this project possible. The idea is the following. There are two kinds of things in LaTeX. There's text mode. I use Elm to analyze and deal with that. And there's math mode, and I figure out what the math mode stuff is, and I pass that on in the rendering phase to either MathJax or Katek. So this is what made the project possible, actually, is Elm on the one hand and these other tools on the other, which take care of the math mode stuff. So finally, here is the top-level rendering function, and you see what it does. It makes a case analysis on the kind of LaTeX expression you have. If it finds that you have a macro, then it renders that using a certain function, which of course calls other functions, and so forth and so forth and so forth. Inline math, that's pretty direct, and so on. So, to really understand this, you have to go down the rabbit hole of function calls, but believe me, it is relatively straightforward. So in closing, a few words about the future. One thing is, this project is very new. I mean, I've been working on MiniLaTeX for about 3 years, but MiniLaTeX.lamdera.app is only about 2 weeks old. So I need alpha testers, people who would like to use it, beat on it, find the errors, find the bugs, let me know about them. Let me know about things that you think are missing, and I'll do my best to take care of that. So please go to MiniLaTeX.lamdera.app, sign up, and let me know about things. Another thing that I need input on is what subset of LaTeX do I really need to have in there? This is a somewhat ill-defined thing because there's no grammar for LaTeX, at least not that I'm aware of. So I've put in what I needed, but maybe that's not everything that other people need. So please do let me know about that. Another thing I want to work on is making better error messages. They're not bad now, but they can be improved. I am working on producing an IDE for the system which will help authors do obvious things like search and replace, but also do syntax highlighting, do various other things, completing a begin-end block so that you keep your code in a valid state to the greatest extent possible. And finally, I'm also working on a desktop app so that you can use this technology on the desktop. You have your files on your computer, and you also have a way of uploading them to a server for sharing with other people. So in closing, I would like to thank the Simons Foundation. They've given me a bit of summer support for this project, and I'm very thankful for that support. So thank you very much, and I hope to be able to answer your questions.